Scientific Notation, Part 1. What is it and why do we use it? By Jeff Simpson. Many different ideas come together to make scientific notation. Here's an example of what it looks like. This video series begins with the simplest ideas. If you already understand these ideas, you can go ahead to the other videos, Part 2 and so on. Or you could watch Part 1 to learn new ways of helping your friends to understand the ideas that are easy for you but seem confusing to them. Knowing what happens when you multiply by 10 helps you understand scientific notation. For example, 3 of these $10 bills we can write as 3 times 10. By the way, of tells us to multiply. And here's a picture of 3 $10 bills, which makes $30, of course. Here's a shortcut for multiplying 3 times 10. Rewrite the number you started with, the 3, and then put a 0 after it. Let's look at 5 tens. 5 of these $10 bills we can write as 5 times 10. Again, of means to multiply. And here's a picture of 5 $10 bills. 10, 20, 30, 40, $50. And here's a shortcut for multiplying 5 times 10. Rewrite the number you started with, 5, and then put a 0 after it. Notice, again, there's a 0 on the end when we multiply by 10. Noticing a pattern like this saves time. We already know what the product will be when multiplying by 10 without having to do any work. Just rewrite the number you started with and put a 0 on the end. So 1 times 10, you just rewrite the 1 and stick a 0 on the end. 2 times 10, do the same thing. Start with a 2, follow with a 0. 3 times 10, 30, and, well, you get the idea. Knowing what happens when we multiply by 10 over and over again also helps you understand scientific notation. For example, let's look at 10 times 10. 10 of these $10 bills is an example of 10 times 10. And here's a picture of 10 $10 bills, which makes $100. So 10 times 10 is 100. Next, let's look at 10 times 10 times 10. In other words, 10 times 100. 10 of these $100 bills would be 10 times 100. So here's 10 $100 bills. 100, 200, and so on till you get to 1000. And 1000 is the same as 1000. So 10 times 100 is 1000. Or 10 times 10 times 10 is 1000. Next, let's look at 10 times 10 times 10 times 10. In other words, 10 times 1000. 10 of these $1,000 bills is an example of 10 times 1000. By the way, the government doesn't make those anymore. And here's 10 $1,000 bills, which makes a total, surprisingly, of $10,000. So 10 times 1,000 is 10,000, or 10 times 10 times 10 times 10 is 10,000. There are many ways we can write 10 times 10 times 10 times 10. You can write it with x's, or you can write it with dots, with parentheses and x's, parentheses and dots. You can mix all these different ways together. Here's another way we can write it. The abbreviation for 10 times 10 times 10 times 10 is 10 with a little 4 written up high. Because 4 tens are being multiplied, 1, 2, 3, 4 of them, 4 tens are being multiplied, we call it 10 to the 4th power. A small number written up here is called an exponent. Here are 4 long ways to write the same thing. 10 times 10 times 10 times 10 equals 10,000. And here's the shorter way to write it. 10 to the 4th power equals 10,000. Using an exponent is the quickest way to write this. Sometimes people get confused and think that 10 to the 4th power is an abbreviation for 10 times 4. Well, it's definitely not. So, is 10 to the 4th power 40? No. 10 to the 4th power is 10,000. The abbreviation for 10 times 10 times 10 is 10 to the 3rd power. Because 3 tens are being multiplied, we call it 10 to the 3rd power. 10 times 10 times 10 is 1,000. 10 to the 3rd power is 1,000. And you can see the 3 refers to those 3 tens that are being multiplied times each other. Which of these is true? 10 to the 3rd power is 30, or 10 to the 3rd power is 1,000? Well, it's not the first one. That is false. It is the other one, because the 3 refers to 3 tens that are being multiplied. 10 times 10 times 10. There's 3 of them. Now, the abbreviation for 10 times 10 is 10 to the 2nd power, because 2 tens are being multiplied. And we call this 10 to the 2nd power. 10 times 10 is 100. 10 to the 2nd power is 100. The 2 refers to the 2 tens, of course. Well, 10 times 10 is 100. We know that. Here's a picture, and there's a group of 10 times 10. One group of 10 times 10. Mathematically, you can write that as 1 times 10 times 10, which is still 100. But you can also write 1 times 10 to the 2nd power equals 100. Now, let's take that idea and do something with it. Here's one group of 10 times 10, but here's another group of 10 times 10. So that's 2 groups of 10 times 10. In other words, 2 times 10 times 10, which is 200. But you can write it as 2 times 10 to the 2nd power is 200. You can do the same thing with 3 groups. Here's 1, 2, 3 groups of 10 times 10. 3 times 10 times 10 is 300. Or 3 times 10 to the 2nd power is 300. So 10 times 10 is 100. 10 to the 2nd power is 100. 1 times 10 to the 2nd power is 100. 2 times 10 to the 2nd power is 200. And 3 times 10 to the 2nd power, 300, and so on. Here are some things to notice about 1 times 10 to the 2nd power, which is 100, of course. 100 is a 1 followed by 2 zeros. 10 to the 2nd power, the exponent is 2. The exponent tells how many zeros to write after the 1. 1 times 10 to the 2nd power is a 1 followed by 2 zeros. Let's look at the same idea with 2 times 10 to the 2nd power, which is 200. 200 is a 2 followed by 2 zeros. And 10 to the 2nd power, the exponent is 2. The exponent tells how many zeros to write after the 2. 2 times 10 to the 2nd power is a 2 followed by 2 zeros. Now let's look at 3 times 10 to the second power. Works the same way. 300 is a 3 followed by 2 zeros. 10 to the second power, the exponent is still 2. And the exponent tells how many zeros to write after the 3. So 3 times 10 to the second power will be a 3 followed by 2 zeros. Okay, let's look at 10 times 10 times 10, which is 1,000, or 10 to the third power. 1 times 10 to the third power is going to be a 1 followed by, guess what, 3 zeros. 2 times 10 to the third power is a 2 followed by 3 zeros, so that was 2,000. 3 times 10 to the third power, 3,000. 4,000, 5,000, and so on. It keeps working the same way. 10 times 10 times 10 times 10 is 10,000. It's 10 to the fourth power. 1 times 10 to the fourth power is a 1 followed by, you guessed it, 4 zeros. 2 times 10 to the fourth power is a 2 followed by 4 zeros, so that's 20,000. 3 times 10 to the fourth power, 30,000. And it keeps going the same way. Here are some things to notice when multiplying 1 with powers of 10. 1 times 10 to the second power is a 1 followed by 2 zeros to the second power. But 1 times 10 to the third power is a 1 followed by 3 zeros. And 1 times 10 to the fourth power is a 1 followed by 4 zeros. Here's some examples of multiplying 5 times powers of 10. We'll start with 5 times 10, which is 50. The picture shows that that is true. Now let's look at 5 times 100. So here's $500. Well, you can actually break that down to make it 5 times 10 times 10, same thing. Or 5 times 10 to the second power. Let's go with a bigger number. 5 times 1,000 is 5,000. And that's the same as 5 times 10 times 10 times 10, which is 5 times 10 to the third power. The exponents are getting bigger. 5 times 10,000 is 50,000, and that would be 5 times 10 to the fourth power. 5 times 100,000 is 500,000, which is 5 times 10 to the fifth power. 5 times a million is 5 million. That's a lot of multiplying tens. And that is 5 times 10 to the sixth power. So there would be 6 zeros after the 5. 50 million is 5 times 10 to the seventh power. 500 million, 5 times 10 to the eighth power. 5 billion is 5 times 10 to the ninth power. Okay, now let's look at a really big number. Wow. How big is it? Well, if you start way over at the right, we've got ones, tens, and hundreds. Then comes thousands, 10,000s, and 100,000s. Then your groups of millions, and billions, and trillions, quadrillions, quintillions, sextillions, septillions, octillions, nonillions, and decillions. Wow. So that's 500 decillions. If you write it in scientific notation, it looks like this. 5 times 10 to the 35th power. You could just write a 5 with 35 zeros after it. It takes more space to write 500 decillions this way And you have to remember all those unusual names to know when you've finally written enough zeros. But it takes less space to write 500 decillions in scientific notation. 5 times 10 to the 35th power. And you don't have to remember all those unusual names for big numbers. Scientists use scientific notation when they're working with extremely large numbers because, well, it makes their calculations faster and easier. Here are some examples. How many atoms are in 1 gram of gold? Well, here's a picture of 1 gram of gold. Not even as big as the end of your finger. A gram is not very much. And atoms are so small you can't even see them. And in case you didn't know, a dollar bill weighs exactly 1 gram. So that's 1 gram of gold. So how many atoms are in 1 gram of gold? Oh, there are over 3 times 10 to the 21st power atoms in 1 gram of gold. That's over 3 sextillion atoms. Here's another example. Bacteria are tiny, single-celled organisms, so small you can't see them. They're not plants, and they're not animals, but they are alive. In 1 gram of soil, not very much soil, it can have up to 1 times 10 to the 10th power bacterial cells in it. A cup of yogurt might have as many as 2 times 10 to the 9th power yogurt bacteria in it. That's over 2 billion bacteria just in a cup of yogurt. Here's another scientific example. Stars are very far away from the Earth. The nearest star is over 2 times 10 to the 13th power miles away from the Earth. That's over 20 trillion miles. Scientific notation always has 3 parts. It begins with a small number, from 1 up to 10. It's followed by a multiplication sign. Then there's 10 to some power, 10 with an exponent. Here's a little test. Is this written in scientific notation? 4 times 12 to the 23rd power. Well, it looks kind of like it, but no. Scientific notation always ends with 10 to some power. But this has 12 with an exponent, and it should be 10. Here's another trial. Is this one written in scientific notation? 7 plus 10 to the 23rd power. Well, no, because scientific notation always has a multiplication sign in the middle. But this has an addition sign, and it should be a multiplication sign, an x. Try this one. 500 times 10 to the 2nd power. Is this written in scientific notation? Well, no, because scientific notation always begins with a small number. Something less than 10, but not less than 1. 500 is too big, because it can be broken down into 5 times 10 to the 2nd power. So 500 times 10 to the 2nd power actually should be written as 5 times 10 to the 4th power. Sometimes scientific notation uses decimals like this, 3 5/10 times 10 to the 6th power. And sometimes scientific notation uses negative exponents like this, 7 times 10 to the negative 2nd power. These will be addressed in the Part 2 video. Well, that's all for Part 1. Thanks for watching. Please share these ideas with other people who can benefit from them.